Good day, students. Today, we are going to learn about writing chemical equations. The first thing we want to understand about writing chemical equations is why we want to write them. Now, a chemical equation tells us the reactants and the products which are involved. Not only that, it tells us the relative amount which they are used. Students, in case for those who do not understand the term relative, allow me to give you an example. Now, consider this term when I say absolute. If I were to say absolute, this would basically means that I will state the actual quantity out. For example, 10 cm cube of A to react with 5 cm cube of B. However, if I were to use the term relative, I would simply just write 2A reacting with 1B. The word relative means in comparison to. So in this case here, the amount of A that is needed is 2 times the amount of B. So a chemical equation would tell you the relative amount of the reactants to be used as well as the products that is formed. Next, a chemical equation also tells us the physical states of the reactants and the product when it is formed and the condition that which is formed. When I am talking about condition, I'm looking at these two things. Okay, the conditions I'm talking about are temperature, as well as pressure. Most of the time, what we will see is this term called RTP, which really stands for room, temperature, and P, pressure. Now, with this in mind, we will now proceed to teach you how and what are the steps to write a chemical equation. Now, students, let us begin with a very simple example. Hydrogen plus oxygen gives you water. As you can see here, this is a very simple word equation. In this word equation, you are shown the reactants and the products. However, it doesn't tell you the relative amounts, nor does it tell you the physical state. To write a chemical equation, the first thing we need to do is to convert these words into formulas. So the thing is, F is for formula. Okay, you need to convert all this into formula. We know that hydrogen is H2, oxygen is O2. And water, okay, remember to draw an arrow, is H2O. Now, once you have convert this into a formula, the next thing that you must remember to do is B. Okay, B is for balance. Now, when you balance an equation, you must basically make sure that the number of atoms of each element, okay, the number of atoms of each element, they must be the same. The keyword is the same on both sides. On both sides. Now, what do I mean by both sides? One side here, on your left-hand side, this is the reactant side. And this side here is the product side. So they must be the same on both sides. Consider first hydrogen. I have with me, as you can see, 2 atoms of hydrogen. Over here, I have also 2 atoms of hydrogen. So which means in this case here, as of now, we have the same number of hydrogen atoms on both sides of the equation. Consider now your oxygen. Now, your oxygen we have 2 atoms of oxygen on the reactant side, but we have only 1 oxygen on the product side. In this case here, it is not balanced. So as a result of this, we need to balance by in this case here, putting a 2 in front of water. So as a result of this, we have 2 oxygen atoms. However, students, when we put a 2 in front here, we get this situation where the hydrogen atoms becomes 2 times 2 and it becomes 4. So now we have to go back to the reactant side and put a 2 in front as well. So that now I have 4 hydrogen atoms on the reactant side and 4 hydrogen atoms on the product side as well. Now, and that would settle the second step. The third step, students, is what we call the state symbols. Student, the state symbols tells us the states of individual reactants. We will put a bracket S to represent solid, a bracket L to represent liquid. We will use a bracket G to represent gas, and we will use a bracket AQ, which stands for aqueous. Aqueous means that a substance is dissolved in water. Now, there's a difference between liquid and aqueous. Now, a liquid is pure. If I were to say sodium chloride liquid, it simply means that I'm taking a solid cube of sodium chloride salt and heating it until the entire cube of solid salt becomes liquid through melting. If I were to say NaCl, sodium chloride, aqueous, it means I'm taking this sodium chloride salt and dissolving it in water. So there is a difference between your aqueous and your liquid. Usually, the question would tell you when a salt is actually going to be aqueous, and subsequently, when you learn further chapters such as your qualitative analysis, you will be able to know what are the salts that will come dissolved in water. Now, how then do we determine whether something is a solid, liquid, or gas? This, I would want you to recall with me the things you have learned in chapter 7. Okay? Students, if you recall, there are some structures which have high melting point and boiling point. Now, these structures, one of them is called a giant ionic structures. The other one, okay, is what we call the giant molecular structure. And the next one is what we call the giant metallic structure. These structures, students, most of them, they have high melting and boiling point. So during a reaction that is actually happening at a room temperature or pressure, they usually comes out as solid state. Now consider with me the other group, which usually have a low melting point or boiling point. And this is the simple covalent structure. Now, this structure, because of the low melting point and boiling point, when the reaction is occurring, it will usually, these structures comes out as gas. Now, students, let's not forget that the giant molecular structure is also sometimes called a giant covalent structure as well. Now, students, with this in mind, I will be able to assign the state symbols over here. Now, hydrogen has a simple molecular or simple covalent structure. Okay? Now, which means that it has a low melting point or boiling point, which means that it exists as a gas. Oxygen, likewise, we know it has a simple covalent structure. So as a result of this, this is going to be a gas as well for oxygen. Now, we know water, although in as much as it has a low melting point and boiling point, but we know, based on our knowledge of water, that at 100 degrees Celsius, okay, it will boil. So usually at room temperature pressure, water is a liquid. In this case here, I did not exactly follow this because there's also sometimes we use our general knowledge of chemicals. For chemicals which are very rare, usually we'll be able to deduce the structure and infer from here. If not, the question will tell you specifically. Now, with this in mind, students, this is a completed chemical equation. Now, let us do one more example. This example is sodium metal plus chlorine to give us sodium chloride. Let us go through this step by step. F is for formula. We will change this into formula first. So I have sodium, Na, plus chlorine, we know is Cl2. And after it becomes sodium chloride is NaCl. Now, the next step is to balance. Sodium, I have one atom here, one atom here. So we are balanced. Let us consider chlorine. I have two chlorine atoms here and one chlorine atom here. So in this case, in order for me to balance, I'll add a 2 here, so that 2 chlorine atoms on the product side matches 2 chlorine atoms on the reactant side. Now, however, in this case, I will cause here to have 2 sodium atoms, and what I'll do is I'll add a 2 here to balance the sodium atom as well. As next, I need to consider the state symbols. Now, sodium is a metal. It has a giant metallic structure. So with a giant metallic structure, we know it is usually solid at room temperature. So I am going to put a solid here for sodium. When it comes to chlorine, chlorine has a simple covalent structure. And we know that because of the low melting point and boiling point that a simple molecular structure have, we know that it is going to be a gas. Sodium chloride, okay, is a giant ionic structure. At room temperature, it is going to be solid state. So student, this is how we write a chemical equation. Now, students, with this in mind, let us learn how to develop, okay, what are the things to take note of if a question, instead of asking you to write a chemical equation, because as you can see here, student, this is what we call, this is a word equation, okay, but this, students, is what we call a chemical equation. Student, there is one more equation that you need to know, and it's called ionic equation. Now, let us consider how we can write an ionic equation. Now, students, in this example here, I have silver nitrate reacting with sodium chloride to give me my silver chloride and sodium nitrate. The question tells us very specifically that your silver nitrate is aqueous. Your sodium chloride is aqueous as well. It tells us, however, that your silver chloride is not soluble and your sodium nitrate is soluble. Let us convert it first from the word equation to your formula, to your chemical equation first. So I'm going to write a chemical equation. The first step, again, F is for formula. I know my silver nitrate, okay, has this formula here, plus sodium chloride, we all know is NaCl. And what happens is it will give us a silver chloride, which is AgCl, and you get sodium nitrate, which is NaNO3. Now, we want to check whether it's balanced. One silver here, one silver here. Silver is balanced. One nitrate here, one nitrate here. Nitrate is balanced as well. One sodium here, one sodium here. Sodium is balanced as well. One chlorine here and one chlorine here. Very good. We have all the atoms balanced. Let us now consider the state symbols. Now, in the question, we are told that silver nitrate is aqueous. So in this case, this is an example that we are told, so we will just write aqueous inside. In the question, it is also told that sodium chloride is aqueous. So we will write aqueous as well. Students, in case you're wondering where I'm referring to, this is taken from your textbook under the writing ionic equation part. In there, it describes clearly that your silver nitrate and sodium chloride are aqueous. Silver chloride, they tell us that it's insoluble. Insoluble means that it is, okay, going to be a solid. And they also tell us that sodium nitrate is soluble in water, which means since it dissolves in water, okay, since it dissolves in water, it is going to be aqueous as well. Now, in writing ionic equations, students, we will have one more step. To be precise, two more steps. Well, we have to rewrite all the aqueous, aqueous compounds as ions. So it's aqueous ions, aqueous aqueous compounds as ions. Why is this so? Because when aqueous compounds dissolve in water, what happens is when aqueous ions dissolve in water, they becomes ions. So that's the reason. That is why aqueous compounds would become ions. So let us do that now. So Ag becomes Ag plus. NO3 becomes NO3 minus. Na as ions is a Na plus. Cl a Cl minus. Ag is a silver, Ag plus. Cl Cl minus. Na plus. NO3 minus. Students, when we are writing as ions, don't forget to write their state symbols. And in this case here, it's all aqueous. Now, student, I have made one mistake. In this case here, I can only take apart the aqueous compounds. When it comes to solid, however, if this is a solid compound, we cannot write it out as ions. Rather, we will have to let it remain as a solid compound. So please take note of that. Now, remember to keep the state symbols there for all your ions. Now, students, after you have written everything as ions, we will need to look on both sides of the equation and identify what we call as number 5, spectator ions. Now, the word spectator, as you know, means that it is standing by the side. It is not participating. You are just watching. Spectator ions means ions that actually do not participate in this equation and reaction. And they, to identify a spectator ion, all you need to do is to look for the ions that appears on both sides of the equation. Remember, ions. So in this case here, if you were to look with me, in this case here, I have my NO3 minus over here. I have my NO3 minus over here as well. I have my Na plus over here, as well as my Na plus over here as well. I have my silver ions here, but however, silver in this case here is a solid, is actually forms a solid compound with a chlorine, so it becomes silver chloride. So as a result of this, even though I have silver ions here, I do not have silver ions over here. So as such, same thing for your chlorine ions. So once we have identified these spectator ions, we will cancel. We will cancel these spectator ions. We will cancel them. Cancel them. So as you can see, I will cancel, 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 and cancel. So once I am done with this, my ionic equations, thank you for patiently waiting, ladies and gentlemen, the ionic equation would be simply Ag, aqueous, plus Cl minus aqueous, to give us your AgCl in solid state. And students, this is what we call the ionic equation. So with this in mind, students, we have actually taught you how to write a chemical equation with step 1, formula, 2, balance, 3, state symbols, and if the questions want us to write an ionic equation, you go on to rewrite all the aqueous compounds as ions, and then go on to identify the spectator ions, and then go ahead, cancel them, and write your ionic equation. So students, this is the video for writing chemical equations. Thank you.